Contingency tables. What are contingency tables? We're going to study, and we're going to see how the contingency table helps us in evaluating the probabilities, particularly the conditional probability. So first we see these tables are used to see the interaction of two different categorical variables, and sometimes this is also called a two-way table. It's a two-way table, and it provides a way of exposing data that can facilitate calculating the probability. It helps in determining the conditional probabilities quite easily, right? Let's see what he's saying first. You can see the interaction of the two categorical variables. Look at that. This is the first categorical variable here. These are the smoking habits. Look at that. These are the smoking habits in the columns, and look at the gender on the other side. So, and both of these variables are categorical variables. The smoking habits of the people is a categorical variable, and the gender is also a categorical variable. And this table gives us an interaction between the values of these two categorical variables, and this is the reason it is called a two-way table. I usually like the word two-way table. It's better. It gives a more meaning what's going on here, and it helps us in calculating the probability problem quite easily, and particularly the conditional probability problem. Otherwise, those problems would have required more difficult formulas to use, which are difficult to grasp. But using this table, we can very easily compute the probabilities. How we are going to do that, I will show you now by taking an example. So let's see the example. The table below describes the smoking habits of a group of asthma sufferers. Based on this table, find the probability that randomly selected person in this group is a number 1 heavy smoker, number 2 male and a smoker, number 3 female or is a non-smoker, number 4 smoker if person is a female, number 5 male if a person is a heavy smoker. So what we are going to do now, we are going to evaluate these probabilities one by one. But the first step, whenever you are given such a table, the first step is you have to complete this table. Look at this. There are empty spots. These total have not been filled, and these total have not been filled. Our first job in this problem is to complete these empty column. We have to complete the totals. Let me do this total first. This is 12. This is 8. This is 20. I'm adding the columns. Now let me add the rows now. 4 plus 6, 10, 10 plus 13 is 23. 8 plus 2, 10, 10 plus 7 is 17. Now you add these rows. You add this total and get a grand total. 23 plus 17 is 40. And you also add these columns here, the total, you do this total. This total. 12 plus 8 is 20, 20 plus 20 is 40. So this total must coincide with this. The row total must coincide with the column total. This is 40 and this is 40. That's your first way of checking, okay, I have done my job correctly. This has to match. This total has to match with this total. That's the first step. Now we are going to compute the probabilities one by one. Let's draw a line here and let's see how we are doing the first problem. Let's see the first problem. First problem says it's a heavy smoker. A person is a heavy smoker. Look at that. How many heavy smokers are there? There are 20 of them. There are 20 heavy smokers out of 40. Remember, we are using this particular formula. The probability of an event A, the probability, let me write the formula here. I'm just writing the formula. Probability of an event A is always equal to a fraction. You write at the top number of ways an event can occur. The number of ways an event can occur divided by number of all possible outcomes. This is the basic definition we have seen in the previous link. We have seen this in previous videos, and we know how to compute this. We have done many problems also. So first one, it's a heavy smoker. Look at that. How many heavy smokers are there? There are total 20 of them out of 40. So the first one will be 20 out of 40, and this is equal to 1/2. The first one was easy, very simple. Look at the second one. The second one says male and a smoker. Look at the word and. Look at the word and recall when you use the word and, it's actually a product probability. We have to use a product rule for the probability. If we were using the rules of probability as discussed in the previous videos, we would have used a product rule, right? But now we are using this particular table, and you will see in a minute how simple it will become using the table. So male and a smoker. Now you try to find out a person here. You see a person which is a male and a smoker. Look at that. There are 6 males which are smoker. Look at that. 6 males and a smoker. So it will be 6 out of 40, and that is equal to 3 out of 20. That's the second one. Third one says female or a non-smoker. Look at the word or. Now I told you in the previous videos, whenever you get a word or, you're actually doing an additional problem. You're going to use addition rule of probability, right? But what we are going to do now, we are not going to use any rule right now. We are going to use this table, and that table will help us. So whenever you have an or problem which use an addition rule, what you do, you add. If the first look at this is a female, you add all the females. You add all the female. Take all these females, right? I'm just telling you a method of doing that. Please pay attention to that. You add all the female. Look at this. 8 plus 2 plus 7. And now look at the second one. Female or is a non-smoker. Look at non-smoker. These are the non-smoker. This is the non-smoker column. You add also the non-smoker. Let me write here. Non-smoker 4 and an 8. But notice something. You notice something. You are adding one thing twice. You are adding this 8 2 times. And recall from my previous video, you are asked, you add all the outcomes for the first event and you add all the outcome for the second event, but you don't count anything twice. So what we are going to do, we are going to remove one of this 8. Let's remove this one of this 8, and now you add 8 plus 2, 10, 10 plus 7 is 17, 17 plus 4 is 21. So we have the third one, 21 over 40. This fraction cannot be further reduced, so we are good with that. That's the second one. Third one, sorry. Now move to the fourth one. Fourth one is a conditional probability problem. Look at the word if. I have put the word, very special words that helps us which rule we are going to apply in uppercase bold letters, right? I have put this so that to draw your attention. Smoker if a person is a female. We have to find the probability that a randomly selected person is a smoker if a person is a female. It's the same thing as saying we have to find the probability of a person who is a smoker given that a person is a female. We know that the person is a female. We know that, okay? So we don't have to worry. It's given to us. The person is a female. Let me clear this one, some of this, so that we know what's going on here. I will try not to delete extra stuff. I want to make sure that you guys are getting it. Okay, that's good. We have deleted the stuff we don't require. Let's now, whenever you get such a problem which says if a person is a female, whatever comes after if, you need to focus on that one. The person is a female. Now, where is the female column? This is the female column. This is the female column. Now, what you're going to do, you're just going to focus. You're just going to focus on this female column. That's it, as if the rest of the table is even not there, as if you have only this, you have this only row. Now you're going to focus only on this row. Remember, whatever comes after the word if, you're going to focus on that particular row or a column. In this situation, it's a row, so I'm going to focus only on the female because it's given to us. The person is a female, that's why I'm focusing on this one. So note that there are total 17 females, and we have to find the probability a person is a smoker, and there are 8 of them. Sorry, not 8, but a smoker is 2. It's a 2 out of 17. So the number 4 will be, it's a 2 out of 17. Why? Because there are total 17 females. There are total 17 females, and only 2 of them are smoker. So 2 out of 17, that will give us the probability for the fourth one. So this is the fourth one. You can't simplify that. Now look at the fifth one. Fifth one is a similar problem. Male, we have to find the probability that a randomly selected person is a male if a person is a heavy smoker. A person is a heavy smoker. Now remember, now we are given this one. We know already that this person is a heavy smoker. This we know that. Now what you are going to do in this situation? You are going to focus only on this column. Only on this column. A person is a heavy smoker. This is given to us. This is the column we are going to focus only now. Look at it. Please pay attention to that. Why I'm going to focus this column only? Because it is given to me a person is a heavy smoker. It is given to me, right? So when whatever the word comes, whatever this statement comes after the word if, whatever the statement comes after the word if, you are going to focus on that particular thing. If it's in a row, you're going to focus that row. If it's in the column, you're going to focus in that column. And look at this heavy smoker. So see that how many heavy smokers are there? The total number of heavy smokers are 20, right? 20. And how many are the male? There are 13 of them. So it's a 13 out of 20. 13 out of 20. So in this way, you see, using this particular table, we are able to compute the probabilities very easily. Had we been using the rules of the probability, the addition rule, the multiplication rule, the conditional probability problem, it would have been a little difficult. We would have got the same answer, no doubt about that. We will have the same answer, but the computation would have been more involved and require more mathematical calculation. But using this particular table, it becomes so easy, and that is the utility of using these two-way tables or contingency table. I hope you understand this idea. Thanks for watching.